Hello everyone, we are back with some more interesting patterns exhibited by square numbers. In last two videos we have seen some three patterns. In this video we'll see two more patterns exhibited by the square numbers. Let's see the first one. Let me write the squares here. So I have written first 6 squares, square of 1, 2, 3, 4, 5 and 6. Now 1, I can write it as 1, so that's fine. 3, I can write it as sum of 1 and 3. 9, I can write it as sum of 1 plus 3 plus 5. 16, and so on. I can keep on going. Now what pattern do you see? I see that all these numbers are odd numbers. And when I wanted square of 1, I used one odd number. When I wanted square of 2, I use sum of first two odd numbers. Square of 3, first three odd numbers. Successive odd numbers. First 4 successive odd numbers. And that way I went on adding successive odd numbers to get the squares. So if I want, let's say, to find square of 10, what I need to add successive odd numbers. How many? 10 successive odd numbers. So if I add 10 successive odd numbers, I get square of 10. You can do this sum and you'll find it is 100. Isn't it a very interesting pattern? And interestingly, the corollary of this pattern also is true, which means, let me take 36 and start subtracting successive odd numbers from 1. So 36 minus 1 is, then 35 minus 3, the second successive odd number. Third successive odd number I have subtracted from this, and I will go on doing that. And I reach 0. And how many steps did I reach 0? 1, 2, 3, 4, 5, 6. And that tells me that 36 is square of 6. So if I successively subtract the odd numbers starting from 1, and if I reach 0, that clearly indicates that the number which I started with is a square number. And this is a very important pattern which can be used even to find square roots or to see if the number is a square number or not. So let's write this. So if a natural number can't be represented as sum of successive odd numbers, then it is not a perfect square. So this pattern not only is just a pattern, it also gives us a rule. Let's see one more interesting pattern. Let me write squares of odd numbers. And if I see here, I see one interesting pattern is that the squares are always sum of two consecutive natural numbers. So squares of odd numbers are always sum of two consecutive numbers. So if I take square of 11, if I want square of 11 to be represented as sum of two consecutive numbers, how would I do? Yes, I can see it is 121, and then I can find it that it is 60 plus 61. But let's say I don't know square of 33 and I want to write it as sum of two consecutive numbers. How do I do that? Okay, so let's see the pattern here. The pattern here is this 4 can be found 9 minus 1 upon 2. So 9 minus 1 is 8. 8 upon 2 is 4. And 9 plus 1 upon 2. 9 plus 1 is 10. 10 upon 2 is 35. So this 33 square can be found as 33 square plus 1 upon 2 or 33 square minus 1 upon 2. What I need to do here is I need to be finding 33 square plus 1 upon 2 plus 33 square minus 1 upon. Now for that I need to find square of 33 and that's not very easy. Can we see another pattern? Okay, let me see. The first number 12. I see pattern between them. So 5. What is 5 minus 1 upon 2? 5 minus 1 upon 2 is. Then I am going to multiply 5 into 2. So 5 into 2 and I am going to add that 2 again plus 2. And that is equal to 12. Let's see whether it works for this one. So if it is 7, I want 7 minus 1 upon 2. 7 minus 1 is 6. 6 upon 2 is 3. So what I'm going to do is 7 into 3 plus 3. 7 3s are 21. 21 plus 3 is 24. Yes, I get the first number. And once you get the first number, the consecutive number is easy. So in this case, let's see for 11 also. So it would be for 11, it will be 11 minus 1 upon 2. 11 minus 1 upon 2 is 10 upon 2, which is fine. So then let's do 11 into 5 plus 5. 11 into 5 is 55 plus 5 is 60. I get the first number. So we can find this as a rule to say whatever is number n, what we do first is n minus 1 upon 2. And let's say we get m. And then the first number would be n into m plus m. Do you get it? So my m is n minus 1 upon 2. So let's say I want 33. So what I am going to do it now. Okay, let me rub something first here. So what is m? M in my case would be 33 minus 1 upon 2 and that is 16. And so my first number would be n. N is 33. 33 into 16 plus 16. So 33 into 16 is 528 plus 16 and that's going to be 544. And the second number is 545. Did you get this? Okay. So these were a few patterns exhibited by square numbers. There are many individual patterns as well, but we will restrict ourselves to these first 5 patterns and we'll solve a few practice sums in our videos for practice to understand how these patterns can be used in a great detail. I am sure you have liked the video. Hit the like button and leave your views in the comments section below. Do watch our other videos on this topic. Subscribe our channel and click the bell icon to get notifications whenever we upload new videos. You may also download the QTube app at the link provided in the video description. Till we meet again, goodbye.